Hello all. Today we're talking about lesson 10.6. We're going to talk about secants, tangents, and angle measures. So, um, objectives: we'll find measures of angles formed by lines intersecting on or inside a circle. Our second objective will be to find measures of angles formed by lines intersecting outside the circle. So, two cases, they'll either be on or inside the circle at first. And then after that, we'll find angle measures outside of the circle, excuse me. A secant is a line that intersects a circle in exactly 2 points. So here we've got secant J. It intersects, if we're looking here, it would intersect the circle at 1, 2 points, and then secant K also intersects at 2 points, all right? So that's just the definition of a secant. An intersection inside a circle. So theorem 10.12 is talking about intersections inside a circle. If two secants or chords intersect inside the interior of a circle, then the measure of an angle formed is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. So here we're talking about vertical angles again. So, well, we look at angle 1, and I'm going to go ahead and also call this angle 3. Those are vertical angles. They're formed by two lines that intersect. Okay? So, angle 1 and angle 3, vertical angles are congruent. So, let's say the measure of angle 1 is equal to the measure of angle 3. Vertical angles are congruent, right? Well, the measure of those two angles is 1/2 the sum of the measure of the intercepted arcs. So what are the intercepted arcs here? Well, arc AB will be an intercepted arc. It's intersected by angle 1, and arc BC is an intersected arc. It's intersected by angle 3. So, okay, we're talking about arc AB and arc BC. So we can find the measure of those angles by taking 1/2 the sum of the intersected arcs. All right. So what about angle 2? Well, angle 2 would be congruent to, let's label that angle 4. Measure angle 2 and angle 4. Those are vertical angles. They are equal to 1/2 the measure of the intercepted arcs. So what arcs are intercepted by those angles? Arc AD is intercepted by angle 4. And arc BC is intercepted by angle 2. So we can use this theorem to find angle measures inside of our circle. All right, so we use intersecting chords or secants. So we've got a couple examples here. Angle A uses chord, or example A uses chords. Example B uses secants. So, all right, let's find X. So in example A, we want to find X. So the measure of, let's just call it angle X, is equal to 1/2 the sum of the intercepted arcs. So arc TU, measure of arc TU, which of course is 130. We'll plug in the numbers in just a moment. And then the other intercepted arc with the vertical angle would be 84, which is arc RS. So, all right, we're going to be substituting 130 and 84. So X, measure angle X equals 1/2. Measure arc TU, again 130 plus RS 84. This is 1/2 of 214, which is 107 degrees would be X in that example. You just pause, go ahead and give example B a shot. All right, kind of the same ideas here, slightly different, with a little bit of problem solving first. All right, so Couple of ways to approach this problem. I think kind of the easiest. Okay, if we're looking for x here, we don't have the intercepted arcs. We don't have the measure of BD. We don't have the measure of AC. There's really not an easy way to find those. We don't know of a way to find those arcs yet. So what I would go with, I would try to recognize that x, and I'm going to equal x, and let's call it y, are supplementary. They lie on the same line, and so those are supplementary angles. I don't know if you guys can see that quite as well as I'd like. So y, those two angles are supplementary. They should add to 180. So if we could find y, which we should be able to because we have the intercepted arcs, right? We know that the measure of angle y is 1/2 the sum of those two arcs, which is 143 plus 75. So if we can find the measure of y, we can use that to find x. So this is 1/2 of what, 218? Which is 109, 109 degrees. Right? And we set x and y, x plus 109, those should add to 180. They are supplementary. They lie on the same line. So if we subtract 109, we should get that x is 71 degrees. So that's one way to find it. A couple other approaches, but I think that's probably the most straightforward way. All right. Example C, here we're finding x. X is an arc measure, so we've got to use that 110 degree angle, which angle I'm talking here, GLH, we're going to use that angle, which is 110. We know that that angle is 1/2 the intercepted arcs. The intercepted arcs are GH, which is x, plus the other arc that intercepts the vertical angle intercepts is KJ, which is 97. And so solving this equation, you're probably going to multiply both sides by 2, cancel out your 1/2. So then you've got 220 equals x plus 97. Subtract 97 from both sides, and you should get that x is 123. So that you can also use this to find the measure of an arc if you have two secants or two chords here. So there's 3 examples of using that theorem. All right. And let's go on to theorem 10.13, which is if a secant and tangent intersect at the point of tangency, so they intersect on the circle, then the measure of each angle formed is 1/2 the measure of its intersected arc. So here at angle 1, we've got angle 1 is 1/2 the intercepted arc. Angle 1 intercepts arc AB. Right? And then angle 2 intercepts arc ACB. Major arc ACB. And so you can see both of those expressed here. Angle 1 is 1/2 of AB. Angle 2 is 1/2 of ACB. So we'll use this theorem a couple of times here in example A and B here. So use intersecting secants and tangents. So scroll so we have the theorem here on example A at least. So use intersecting secants and tangents, find each measure angle QPR. QPR right here. So the measure of angle QPR is 1/2 the intercepted arc. What is the intercepted arc? The intercepted arc would be arc PR. So measure of angle QPR is 1/2 of 148, which then leaves us that would be 74 degrees. So measure angle QPR is 74 degrees. All right. And then here we want to find the measure of arc DEF. So that is major arc here. The outline there. So that's the arc we want to find, DEF. So to find that arc, well, I think if we found arc DF, this part, we just kind of subtract DF and 360. So we can use that angle measure, the angle D. So 64 degrees is equal to 1/2 the intercepted arc, which would be arc DF. Again, not the arc we're looking for, that would be arc DF. That'll help us find arc DEF. All right, so if we multiply both sides by 2 here, we get that arc DF is 128 degrees. Still haven't found DEF, the green here, but we can use that. The whole circle is 360 degrees. We can subtract arc DF, which would give us the arc we are looking for, arc DF. So 360 minus 128 would give us 232 degrees. Measure arc DF. All right. So there's another couple examples. Those intersect on the circle. The last example we wanted to talk about was when they intersect outside a circle. And it's going to be dependent on what case we have here. So theorem 10.14, if two secants, a secant and a tangent, or two tangents intersect in the exterior of a circle, 3 cases, right, then the measure of the angle formed is 1/2 the difference, subtraction, of the measures of the intercepted arcs. So here we've got angle A. If we're looking for angle A that intersects outside of the circle, that is 1/2 the difference of the intercepted arcs. So DE minus BC. Okay, again, even if it's secant tangent, angle A outside of my circle, it's 1/2 the difference of the intercepted arc. So again, DC minus BC. And same thing, even if it's tangent, okay, it would be 1/2 BDC minus BC. All right. So we're using difference when they intersect outside of the circle. So find each measure. Find the measure of angle L. So this is the two tangents case. So this is more similar here to the two tangents case. These rays are tangent to the circle. So to find the measure of angle L is 1/2 the difference of the intercepted arcs. So what are the intercepted arcs here? Okay, the larger of the two would be HJK. And the smaller arc would be just HK. All right, and we want to find the difference of those two. Of course, we have HK already is 102. Okay. HJK would just be 360 minus 102. The whole circle minus the piece that it's not, so 258. And then we've got 1/2 of that. It's going to give us the measure of angle L. Again, so to find, I guess, I might have skipped through that pretty quickly. So to find HJK, this piece, I just used 360 minus 102. That gave me, I was just taking away this piece, HK. Okay. All right, and that gave me HJK, the green there. So 258. And then, so if I'm solving this to find angle L, it's just 1/2 of 156, which is 78 degrees. All right, so angle L is 78 degrees. All right, now we're going to use the same theorems here. We've got a secant and a tangent, so kind of similar to this case, right, secant and a tangent. We've got the angle measure. We want to find arc CD, right, in this case. So we use that again. So in this case, measure angle A equals 1/2 the difference of the intercepted arcs. So arc CD is intercepted minus the other intercepted arc BC. And so plug in what we know. Angle A, of course, 56 equals 1/2 arc CD. That's what we're looking for. Minus BC is 95. So again, solve this equation. Get rid of the 1/2, multiply by 2. 2 times 56, 112 equals our CD minus 95, so we'll want to add 95 to both sides here, and we get that 112 plus 95, 207 is equal to our CD, which is what we were looking for. So we've solved that problem. Right. We'll go ahead and skip this example for now. Here we would just use that we've got 2 secants intersecting outside of the circle. I'll leave that one for you guys. Kind of a summary of how secants, tangents can intersect. And then your homework here, 8 through 26. So, and thank you for watching.